This first problem we're just going to go over. It's like what we've been doing. So in this case, if I have the square root of 2x minus 1, what is my u? 2x minus 1. So du would be 2 dx. So I would need to add a 2 right here with that dx, which means I would need to put a 1/2 out front. And so now, if we convert to our u's, this part right here is u, this part right here is du. So we've got 1/2 integral of the square root of u du, or if we want, we can write that 1/2 integral of u to the 1/2. And then we will just integrate here. So u to the 3/2. The 1/2 will be out here. Actually, I'm just going to do this. Let's do, since there's just one term, we got that 1/2. We're dividing it by 3/2. So 1/2 divided by 3/2 is going to be just 1/3 u to the 3/2, and I should put a plus c here. And so if we plug in our x's, we've got 1/3 2x minus 1 to the 3/2 plus c. All right, so from what I can tell so far, you guys seem to be doing pretty well with this. We've had a few questions on homework, but most everybody seems to be able to complete it. Hopefully tomorrow, quiz will be good. Stuff like this will be on the quiz tomorrow. Now, let's look at this next problem and look at how it's different. Okay, it almost looks the same. But yeah. So what's the problem with this one? Okay, you've got these two things multiplied, and this x out here, that's not your du, right? So like if you tried to solve this like the last problem, you'd have u equals 2x minus 1, du would be 2 dx. You could put the 2 here, you could put the 1/2 out here just like we did before, but when you go to replace, you've got the u here, you've got the du, but you've still got the x on the outside. So let's go ahead with what we've got here. We've got 1/2 integral of x square root of u du. I cannot integrate that when I've got the x and the u. I'm taking the derivative with respect to u. So I need this x right here needs to be replaced with something with the u. Right? It's got to turn to some sort of u, or we can't integrate this. So, although this problem almost looks like the one before, it's very different, and it cannot be done the way we've been doing. We've got to do something different. So what we're going to do for a problem like this is we're going to use u equals 2x minus 1. Now, we're setting that as a fact, u equals 2x minus 1. I need to replace just the x, right? That's all I've got over here that needs to be replaced. So I'm going to solve this equation for my x. Okay? So I would add the 1, so u plus 1 would equal 2x. and I divide by 2. So u plus 1 over 2 would equal x. So if we're assuming u equals 2x plus minus 1 is true, then u plus 1 over 2 equals x also has to be true. So what we're going to do now is we're going to take u plus 1 over 2 and we're going to replace our x. So we've got 1/2 integral of u plus 1 over 2 times, I'm going to make this u to the 1/2 du. Alright, questions so far? Alright, so we've got everything plugged in. This is going to be a little bit more difficult to integrate than the ones we've had before, but we can do it. So here, this 2 right here, that's really just a coefficient, right? I'm going to pull this on the outside right there. And these two things are multiplied, so that's okay. And then I'm also going to distribute that u to the 1/2 in the numerator. So that 2 in the denominator is going to go out front, so that will give me a 1/4 integral of, and then I'm going to distribute this u to the 1/2. Right now that's u to the first power, so that will be u to the 3/2 plus u to the 1/2, and we'll have a d here. All right, questions? Alright, so now we need to integrate, and we can integrate this using the power rule. So we'll have 1/4, I'm going to put a bracket here, we'll have u to the 5/2, and that'll be 1/5/2, which will give us 2/5, plus u to the 3/2, and then 1/3/2, which will give me 2/3. And then we'll put a plus c over here on the end. Okay, we cannot leave it like this because we've got to have our x's in. So on free response, then we'll plug in our x. 2/5 will have 2x minus 1 to the 5/2 plus 2/3 times 2x minus 1 to the 3/2 plus c. On free response, leave it here. The problem is that there's probably going to be at least one that they give us that's not free response, so it's multiple choice. So if this is multiple choice, they're probably going to simplify it further. And if they simplify it further, this is what they're going to do. Notice that you've got a 2x minus 1 here and a 2x minus 1 here. All right, those match. So those can be factored out. So we can take out here with that 1/4, we can take out a 2x minus 1 to what power would you take? 3/2. Take your lowest power, right? So that will leave you on the inside, you'll have 2/5 times. If I'm dividing this by 2x minus 1 to the 3/2, I subtract my exponents. 5/2 minus 3/2 gives us 2/2, which is to the first power, right? So I just got 2x minus 1 here. And then I've got plus 2/3. And whenever I divide this by 2x minus 1 to the 3/2, those just cancel each other out. So it's just 2/3 times 1 here. The plus c, just leave it on the end. Don't mess with it. And then you can distribute. So you got 1/4 to 2x minus 1 to the 3 halves. And we'll get 4/5 minus 2, and 4/5 x minus 2/5 plus 2 over 3. And then we need to add 2/5 and 2/3, so 15 would be our common denominator. So that would give us 6 over 15 plus 10 over 15, so we get 16 over 15. So 1/4 2x minus 1 to the 3 halves times 4/5 x minus, oh wait, one of them's negative, it's not 16. This is, the 2/5 is negative, so that's a negative 6, so it should be 4 over 16. 4 over 15, I mean. So minus 4 over 15, like so. And then they may take this, they might leave it like this. They'll probably take this 1/4 and kind of move it here and then distribute it. But, because I could have 2x minus 1 to the 3 halves. So if I distribute that, though, 1/4 times 4 over 5, what happens there? 4's cancel, so I get 1/5 x, and then here I'll get 1/15, and I've lost my plus c along the way. Try not to lose it. So something like this might be what they give you. They could do some other crazy stuff with fractions there.
How do you get 4?
So when you multiply 4/5 by 1/4, then the 4 in the top of that 4/5 cancels with the 4 in the bottom of the 1/4. And same thing for the 4 over 15 when you multiply by 1/4. So on free response, stop here. Unless you need it for the next part, which normally you don't on a problem like this. Unless you need it for the next part, stop right here. Do not try to do any of the stuff that I just did. But if it's multiple choice, you know, the answer choice might look like this, and you've got to try to get it to match there. Okay, let's do another one. Actually, we're going to skip this. Okay. Let's do this one. So, similar thing is going to happen here. You pretty much have to let u be 3x plus 2. So that would make du 3 dx. You could put the 3 here with your dx. You could put the 1/3 out front. But whenever you do this, then you're going to get 1/3 the integral of, well, actually, let's do this, x times u to the negative 1/2 du, right, because you're putting the 3 here and the 1/3 out front. And so if you have that, you got to replace this x right here. So to replace that x, we're going to go back up to what we said the u was. And so this would be u minus 2 equals 3x. And we would divide by 3. So u minus 2 over 3 is our x. And we're going to take that and plug it in over here. So got 1/3 the integral of u minus 2 over 3 times to the negative 1/2 du. Okay. Questions? Once you get it here, I sometimes think it's a little hard to get this ready to integrate because you can't integrate it like it is. So what could we do to get it ready to integrate? Okay, what are we distributing? U to the negative 1/2. So that, yeah, we can take that denominator and we can put it outside. As long as it's a coefficient and we don't have a variable there. So we can make this 1/9. And then we're going to have, when we're multiplying, we're adding our exponents. So 1 plus negative 1/2 gives us just u to the 1/2. And then we'll have 2u to the negative 1/2. Again, try not to lose that du until you've replaced it with the plus c, because I'm afraid they're going to count off if you don't have it. Are we okay here? Alright, now we have to integrate, so the 1/9 is going to stay out here. We're going to have u to the 3/2, and then we'll divide out front by 3/2, which will give us 2/3. And then we'll have u to the positive 1/2, and we'll divide out front by the positive 1/2, which will give us, or by the, yes, divide by the 1/2. Ooh, somehow my brain's not working on that. It should be 4. Alright, negative 2 times 2 over 1. Yep. So negative 4 and plus c. We could, if we want, we actually, if you want, you could go ahead and factor out that u to the 1/2 before you plug the numbers back in. It really doesn't matter. Let's try that this time. So, like, if we want to factor out that u to the 1/2 here, that will leave us with 2/3 times u minus 4 plus c. And then you could plug in, and what did we have on this one? It was 3x plus 2, so 1/9 times 3x plus 2 to the 1/2, 2/3, 3x plus 2, minus 4 plus c. And they might write it like this, 3x plus 2 to the 1/2 over 9 times, you're going to get 2x plus 4/3 minus 4 plus c. And then you'll get 3x, or let's not even write it like this. The square root is 3x plus 2 over 9 times 2x and 4/3 minus 4 over 1, you would multiply by 3 there. So you have 4/3 minus 12/3 would give you negative 8/3. You might see it like this. You might take that 9 and distribute. Let me show you something else even crazier that they might do here. This is even crazier. I hope they don't, but they could. So, like, let's say if we were trying to combine these right here, that 2x minus 8/3. Right now that's over 1, so you can multiply that by 3 on top and bottom. So you get 6x minus 8 over 3. So you have the square root of 3x plus 2 over 9 times 6x minus 8 over 3, which would give you 6x minus 8 times the square root of 3x plus 2 over 27 plus c. They might do something like that. Possibly. Who knows what they could possibly do. So this is really all depends on what they give you as far as multiple choice answers go, what you have to do there. What I would like for you to do as you do your work is I want you, on the odd problems, check the back of the book and get your answer to match the back of the book. That's kind of good practice for multiple choice because they usually have simplified that way down. On the even problems, it's all right with me if you leave it way back up here. Actually, we could have plugged in your x right there and left it here if you want. So your assignment is going to be on page 342, and we are going to do 63 through 70, but number 69 is going to be a bonus. And I can't remember right now exactly why I said it. I really didn't look at it yesterday, but I'm assuming it's pretty difficult to do. You got the right answer for 69, so you'll be able to get, like, you will have the right answer for 69 in the back of the book, but you must show all work for that. And we'll say, I think it's a pretty hard problem. We'll say plus 3 on the test. There. For that one. So, skip over 69 as you do your homework at first. On the odds, make sure you check the back of the book and get your answer to match those. On the evens, it's okay with me if you leave it, without simplifying.